So today we will be looking at another video on how to solve radical equations. So last time we looked at using substitution, and this time will be a much simpler technique that you guys might be more familiar with. So it's using the conjugate. So whenever we have a radical expression like 4 plus root 3, if we multiply its conjugate to itself, we get, let's see, this will be 16. It'll be 16 minus 9 equals 7. So we get, 16 minus 3, sorry. 16 minus 3. So essentially what I mean here is that if we multiply a radical expression by its own conjugate, then we get rid of the radical. So this is why if we have a radical expression on the denominator, then we multiply the conjugate to both the numerator and the denominator to get, if you multiply this with, so it's this, we multiply the conjugate, and then this will become 1. Yeah, so essentially, this is how we do it. And the first problem we're going to look at is going to use this exact technique, except that the expressions in the radical and outside the radical are going to be unknown variables. So even if you get, like, for example, like 1 plus root of 2x plus 1 or something in the denominator, then don't worry, just use the same technique, because you'll be used to using the conjugate to rationalize denominators or like do other stuff to get the real part, and to get not the real part but the rational part. But really, if you're solving math problems and you get unknown variables, you can do the exact same. So this is just the idea of just applying your knowledge about a certain thing to solve more general problems. So let's start this first problem then with this idea. So the first problem I'm going to give you is going to be quite simple. 1 over 1 minus square root of x minus 2 plus 1 over square root, 1 over 1 plus square root of x minus 2. So actually I'm going to move that. Wait a second. I'm gonna move that. Okay, I give up. So basically, we have a radical expression at the bottom. So we're gonna do this by rationalizing the denominator for each of them by multiplying the conjugate for each of them. So if we rewrite these a bit more spaced out, if we multiply the conjugate to both sides, and you realize, you actually, for those who have close observation, who are good at observing things, you will realize that these two things are conjugates of each other. So there might be some cancellation probably when we rationalize each of them. So we're just going to first rationalize each of them. And then what we're going to do is simplify these. So multiply them. So the bottom becomes, if we do it straight away, it'll be 1 minus x minus 2. And then the top will be 1 plus square root of x minus 2 plus. And the bottom will be this here. And it'll be like this. And then we realized, so we observed at the beginning that these two are conjugates of each other, which means that if we rationalize the denominator, then we're going to get the same denominators, which is pretty good because we can easily join the fractions together. And we realized that, so the common denominator here is just going to be 3 minus x. 3 minus x. And then at the top is 2. Oh yeah, the problem said this expression is equal to, let's say, what value was it? 2. It was 2. Yeah. So if we simplify this, these cancel out. We only add them, and then we get 2 over 3 minus x is equal to 2. So if we solve this equation, then we get x is equal to 2. So yeah, it was a pretty simple problem, and all we did was just rationalize the denominator, regardless of if it's an unknown variable or not. And we knew that this was the correct way. We knew that it was the correct way because, yeah, you could have just multiplied the lowest common multiple of these two denominators to get rid of the fractions, but we rationalized them because we noticed that these two, yeah, I didn't mention it at the beginning, I just mentioned that observation in the middle, but normally if you have a radical expression in a fraction, your first instinct should be to rationalize it. But if you want to be more intentional in your method of problem solving, then it will make sense to say that you observe that these two are conjugates of each other. So if you rationalize them, you will get a common denominator and things might get simpler. So yeah, that is how you do this problem. And it provides some insight into radical equations. And then we're going to look at a second problem, which is a bit more interesting. So it's a bit more interesting than this one. So the problem says solve for x if square root of 3x plus 1 plus minus square root of x plus 4 is equal to 7. So for those of you who are good at solving radical equations, your first instinct would be to put this radical on this side, square both sides to get rid of this radical, and then you will get one radical expression here. So you isolate it again and then square it again, and then you'll be getting some quadratics, but will you be getting quadratics? Yeah, you'll be getting quadratics, but you'll have all the radicals gone, so you'll be able to probably solve the quadratic. But really that is a good technique too. That is a very basic technique, and if you can use that technique, then it's better to use that. But here we're going to use the conjugate to provide a more interesting solution to this problem. So let's say this is A. Okay. Let's say this is A and let's say this is B, including the radical. Then this expression says A minus B is equal to 7. A minus B is equal to 7. So let's see what we can do with A and B to get a simpler expression to get an expression. Well, let's see what we can do with A and B to get an expression that has no radicals. So the most simple thing would be squaring A and squaring B. So if we square A, then it's going to be 3x plus 1. And if we square B, it's going to be x plus 4. So if we square them, the radical disappears. It's pretty basic. So we just square both of them. But we don't know what to do with them yet. So are we adding them, or are we multiplying them, or what? So we'll just leave it like this for now. And we'll pause and ponder about this for a bit. So we want to somehow make another equation. So we have two radicals at this instant, and it'll be much easier if we have just one radical. So we don't want to go through that procedure of isolating and squaring and isolating and squaring twice. But using this method, maybe we can have only one radical. So maybe we can get rid of one radical. So here we have A minus B. We have an expression for A minus B. But what if we have an expression? If we find A plus B, if we have A plus B, so whatever they are, I mean we know what they are. But if we have something for A plus B, if we know this, then if we add these two, then one of the radicals, if we add A minus B to A plus B, then B is going to cancel out. So 2A is going to be equal to some expression, and it's probably going to be linear. But essentially we want this part to have no radical. This part, as we see later on, we will see that this part will have no radical. But here if we get a plus b, if we find a non-radical expression for a plus b, if we find a non-radical expression for a plus b, then if we add these two, then we're going to get rid of one radical on this side. So we're going to have one radical expression and a non-radical expression here. So that will just give us one radical, and then we can just square and then just solve it instantly. So we want to find it. So my conclusion is we want to find an expression for a plus b, a non-radical expression. And it might seem impossible at first because, I mean, how can you go from this to this? But again, we know that a squared and b squared give non-radical expressions. And we want to see if we can use a squared and b squared to provide a relationship between a minus b and a plus b. And then we see that if we do difference of squares, this is equal to a plus b times a minus b. So this is equal to a plus b times a minus b. So this is, so firstly, so let's try, if we do a difference of squares, let's see what we get in this expression. If we do, so if we minus this, then this just becomes 2x minus 3. So that is a squared minus b squared. Okay, I'll just write it at the bottom. A squared minus b squared. This notation is really weird, but just bear with me. So yeah, it's not a fraction, it's just like an indication that that is the variable. So a squared, this is a squared minus b squared. So a plus b would be a squared minus b squared divided by a minus b. So it will just be 2x minus 3 over 7 just by like dividing this by this. So like I said, so like we wanted, we actually got a linear expression. We got a non-radical expression on this side. So if we add these two equations, we get, oh, I'll just write it in here to not make it confusing. So if we add these two equations, then this side will be non-radical, this side will only have one radical. So if we add those two, we get this, as we wanted. So all we have to do now is just square both sides. So if we just evaluate this, this will be, and then I'll just skip ahead. So if we square both sides, then we simplify to this. And you'll realize that it's not really necessarily that simple, but we'll try solve it. This is a pretty not nice quadratic, but it does simplify to something simple. So we get x equals 5 or 96. Okay, but we have to be careful. These are not the two solutions because if we have to plug them back in. So if we put 96 in, then this will be 289, square root of 289 minus square root of 100, which is 7. But then if we put in 5, this will be square root of 16 minus the square root of 9, which is not 7. So surprisingly, we got two solutions. We did the correct math. But this solution doesn't work. But the thing with radical equations and probably other kinds of topics in the other kinds of equations, there will be cases when you have to put the answer back in. So like even in Olympiad problems, the last point that you have to get will be to put the answers back in, put your own solutions back into the problem to see if it actually works. So that's because it might have to do with like squaring, and yeah, you didn't do the math wrong. It's just in your procedure you might have ignored an important mathematical fact. But anyways, always put it back in and check if it works or not. And we realize that 5 doesn't work, so our answer is 96. So yeah, this problem is kind of really weird, and you might think it might have been easier to just do that method of isolating and squaring and isolating another radical and then squaring, but yeah, to be honest, that method might be easier if if it takes longer for you to think of this and then do the algebra, because but then I'll tell you, the algebra that you'll do for isolating squaring as well would not be easier than this. But then but I feel like this problem, this solution is much more interesting because the intentions behind it are quite creative. Because just squaring is like not that interesting, but kind of using the conjugate and like using just trying to think of another way to do the problem, it's just really interesting. So like in some ways I think maybe we can say we complicated the problem, but sometimes when you do math problems, finding the easiest way is not necessarily the fun way. Sometimes even if it seems like we're overcomplicating the problem, if it's more elegant, if it seems more creative, I think that's how math problems become much more fun. So yeah, I hope you enjoyed this video and hope to see you in my other videos.